This is a live eBay product page, pulled in 3.5 seconds. 1100 kilobytes of HTML, no proxy setup, no browser automation, and no block. The same request, written the obvious way in Python, gets refused in 1/10 of a second. Here is exactly what the difference is. Scraping a website is really two problems, and most tutorials only solve the easy one. Problem 1 is parsing, pulling the title and the price out of the page. That part is genuinely simple. Problem 2 is access, actually getting the page at all, repeatedly, without being blocked. That is the part that eats your week. In the next few minutes, I will show you the naive version failing, the fix, and how to scale it. One note before we start. Everything here is public page data. Public data is not personal data, and if you are collecting anything that identifies a person, you need a lawful basis for it. So why does a site refuse you? 4 layers, and they stack. First, rate limiting. Too many requests from one address. Too fast. Second, IP reputation. Data center ranges are flagged before you send anything, which is why the free cloud box you are testing from is the worst possible place to scrape from. Third, fingerprinting. Your headers, your TLS handshake, and your request order all say script, not browser. And fourth, the markup itself moves. Any one of these on its own is a fixable afternoon. All 4 at once, changing under you, is a maintenance job that never ends. Let us be fair to the DIY route, because it does work. Here is the whole thing. Requests to fetch, beautiful soup to parse, 1 selector per field. On a site that does not fight back, this is genuinely all you need. I ran it against books.toscrape.com, which exists for exactly this purpose, and it returned 200 OK in under a second. 9 kilobytes, parsed, done. Now the same 6 lines, pointed at a real eBay listing. 403, forbidden, 0.13 seconds. It did not even get far enough to be rate limited. It was refused on site. And this is the honest trap. You can beat that. Rotate residential proxies at a couple of dollars a gigabyte and up. Add a captcha solver, match browser fingerprints, each fix works. Together they turn a 6-line script into a system you now maintain forever. Here's the other route. Same target, 1 call. Universal/get, with the URL you want and your key. What comes back is the page, URL, content type, and the full HTML. 200 OK, 3.5 seconds, 1100 kilobytes for the same eBay listing that just refused a plain request. The proxies, the retries, the fingerprinting are handled, and not by you. Then you parse it exactly the way you already know how. Same beautiful soup, same selectors, because it is the same HTML. That is the split worth internalizing. Access is the hard problem, and it is the one you hand off. Parsing is the easy problem, and it stays yours. And if the site you want is one of the popular ones, you can skip the parsing too. There are dedicated endpoints that hand back structured fields directly, which we will get to in a second. Scaling this is mostly parameters. Country routes the requests through that region, which matters more than people expect. Pricing, availability, and language all change by country. Parse controls whether you get raw HTML or structured output where that is available. And to go wide, you loop, paginate, and keep your concurrency sane. On cost, this is 5 credits a call, flat, and a free key starts you at 5,000 credits. So your first 1,000 pages cost nothing, with no card. And if you would rather not write the parsing at all, there are dedicated endpoints for around 230 popular sites. eBay, Amazon, LinkedIn, YouTube, Google, and so on, each handing back clean fields instead of markup. So, 3 things. Parsing is easy, and it stays yours. Access is hard, and that is the part worth handing off. And the naive version fails in 1/10 of a second on any site that matters, so test against a real target, not a practice one. There is a free key in the description with 1,000 pages on it, no card needed. And if the site you want is eBay specifically, the next video does that one end to end. Thanks for watching.